Hey, quick question. So, does the midterm include dictionaries? Or
Yeah.
So
Yeah, everything up
every
until
class
today.
up until today. Okay.
Yeah.
Thank you.
All right. So while people are seated, are setting themselves, I'm just gonna show a slideshow of the dogs that they took pictures of during the marathon. No. So the dogs, like like when you're sorry, I should say the half marathon. Don't want to overclaim. So so like during the marathon, you can do it as well. People just go and be spectators and like they like cheer on the people who are running, and they bring their dogs, their kids, whatever it is. Yeah. Okay, I think we already saw this one, and people are still coming in. All right. Yeah. So So I was showing the slideshow of the dogs from the half marathon that I ran on Sunday morning. If you go to my LinkedIn or whatever, you can click this link and see the dogs for yourself as well. I was running, and then Professor Amy Basilak from Mechanical Industrial Engineering actually ran the full marathon. So yeah, that was good. Yeah. All right. Okay. So yeah, and my time was 2 hours, 30 minutes, but I did take like 200 pictures of dogs. And so I could have been faster. And oh yeah, I happen to have something with me. They give those to everyone, unlike in Angsai. So, so, however, unlike an Anxi, you pay just $15 for one of those and you get one if you run. I understand that tuition these days is more expensive or something. Okay, all right. So week 8, welcome. So the midterm, as announced previously, everything up until and including today is potentially testable. Hopfield networks, are they on the midterm? Well, yes, they are. There will be a question about them, I promise. However, not different from the stuff that we have done either in the quiz or in the lab. So nothing, like if you're worried about more conceptual stuff, don't worry about it. If you're worried about the quiz example or the lab example, well, do worry about it, but in a constructive way, just study up until you're not worried. So it's not going to be literally the same, but it's going to be inspired by one of those. So Wednesday is going to be more problem solving. This course really is mostly about problem solving. There's not going to be technically any new syntax, but again, this course is mostly about problem solving. However, I will also not, do something that when writing the midterm, I will have expected you to know if that grammatical construction makes sense to you. So I do encourage you to check out the old midterms. I encourage you to actually write one under, similar conditions to what you've experienced this morning in ESC180, for example, right? So like sit down without any distractions, but, sit down and try to do it for 2 hours, see how it goes. So marking schemes, a lot of people are asking me, like, how is that going to be graded? And the answer is just go look at all the marking schemes for the old midterms on the front page. It says exactly how they were graded. This year is not going to be different. So, okay. What to expect on the midterm? So again, nothing much new except that the prompts are new. So similar format. Old midterms, if you look at them, they're, a mix of relatively easy problems and then problems that are solvable using approaches that are similar and, sometimes identical. Sometimes they're verbatim the same problems to what was seen, in the lab examples and the lecture examples and the online exercise examples and stuff like that. Sometimes, not always, there is kind of what I call like the A+ question, where I'm saying, okay, like not everyone here is going to get an A+. The people who solve this are going to get an A+, maybe. And that's kind of how the question is designed. So here's, I'm not saying everyone, but here's how most profs, I would say, approach composing problems. So sometimes you're saying, okay, like I'm going to give something that they really should all know. They've seen it in the lecture or in the lab. They should know this. Another type of thing is, let me give them something straightforward. So something that everyone should get because I want to give some, easy quote unquote marks. No such thing in Anxi, but still. And that's because, at the end of the day, the mark is going to be, whatever composed of one block that probably everyone or most everyone should get, and then another block that's a little bit more difficult, and then maybe a smaller block that's kind of the A+ question. Okay. And that is how most people think. Like, let me give a range of questions and let me try to do something that's kind of inspired by the lecture or the lab. This part, I think, is maybe not obvious to people, but it is now obvious to me now that I've had some experience. So if you look at the exams at Waterloo, but even like the exams at whatever, York or Ryerson or whatever, you look at them and say, well, like those seem like really difficult questions. However, did most students get them? And the answer is, well, the answers were given out in the lecture. That's how. So it's hard to come up with something that's an exam that's kind of genuinely kind of stuff that's not in the lecture, and that's still, not completely straightforward. So that kind of means for you that if you are stuck and you see a question on the midterm on the exam in this course or any other course that looks like it's difficult, that looks like it requires some kind of intricate path to a solution, a lot of the time, the reason is that something like that, or something which could use an approach like what you've seen in lecture, has been in lecture. Okay, so, and the key is there's not that many lecture or lab examples that you've seen, like not very few, but also like, I don't know, like 70, 80, 100, like not more, right? So just think about those. I'm not saying memorize them verbatim. That usually does not work. I often get, one or two students who, well, maybe they have photographic memory, or maybe they don't, and they've really just tried very hard, where they just like dump solutions to previous midterms from my webpage to this year's midterm. And that usually does not work. But kind of understanding and feeling like, okay, like now that I've looked at this example, I can reproduce it from scratch. That's for this course, or for other courses probably, that probably works pretty well. That was a second order thing. Okay, to first order, you were accepted to ANSI because you had excellent grades in high school. You're a good student. Just do what you normally did in high school. That should be the default approach, recognizing that it doesn't work for everyone. So another thing, and we'll see an example of this later on today, if you don't see all the way to the final answer, the thing to ask yourself is, okay, like, how can I move closer towards the final answer? What can I compute? Because in this course, we're computing stuff. So what kind of quantity can I compute, or what kind of object that I can compute that kind of looks like that will get me closer to the final answer? And once you've computed that, try to move forward from there. Sometimes it works, of course, sometimes not, but it's better than just sitting there and waiting for, the moment of clarity where you see all the way to the final answer. That sometimes doesn't come. Yeah.
So for handwriting the code, does it matter what we write in pen or pencil?
It does. So the question was pen or pencil. That doesn't matter. So we scan. So the reason, well, there are two reasons that pencils used to be banned. One is sometimes people would like erase their answers after they've gotten the test back and then submit that for a remark. And obviously we don't like that. Not an issue anymore because we scan your midterms. The other issue was like more an engineering issue where the scanners weren't good enough to scan in pencils. That's not the case anymore either. So whatever you want, we'll thank you to not make things messy on the test, but if you do, that's fine as well. We'll figure it out. So the one time, again, and I'm telling you this because it doesn't matter anymore. So the one time back when we did remarks on paper, someone wrote in pen, but then retyped the midterm questionnaire and then gave, another correct answers, and then marked themselves incorrectly and then submitted that for a remark. And I was impressed by the effort, and it almost worked. But if you look at my midterm templates, they're really pretty, and you cannot easily reproduce them in Word. And that student did an admirable job, but did not succeed. So okay. And then like one final thing, how many people know the Carnegie Hall joke that I'm referencing? Oh, no one. I'll tell you a Carnegie the joke. So the joke goes, so it's told about like various famous musicians. I'll tell it about Jascha Heifetz, the famous violinist. So Carnegie Hall is a famous concert hall in New York City. New York City is known for having a lot of tourists. So anyways, this tourist accosts Jascha Heifetz, the famous violinist, on a street in Manhattan and says, sir, how do I get to Carnegie Hall, please? To which the answer was, practice, young man, practice. The point is, all of those strategies, they're well and good, but mostly what you want to do is write as much code as possible, test it. Python keeps you honest. If you just, write something on paper and kind of look at the vibes, like, does it look right or not? That's not necessarily reliable. You really want to test your code. Unlike in other courses, that is possible in this course. You can check. Sometimes, by the way, people come to me and ask, like, does this look right? And I said, well, just try it. Like, if it doesn't work, then it's probably not right, or at least not right enough. And if you debug, if you try to get it to the answer, you also learn what a good solution looks like, to the point where you will be able to just glance at the solution and answer the question, does it look right or not? But that's, I think, the only way, just like with, playing the violin or, kind of swimming, riding a bike, whatever, like we mentioned. Okay. Okay. All right. So that's that. With that, let's move on to practicing stuff. So the question, the problem that we were solving from Friday was reverse lookup in dictionaries. So what we mean by reverse lookup is, given a password, get me all the usernames that correspond to that password. Okay, so let's do that. Okay. Yeah. Okay. So this was, I guess, like, light chatter is fine, but yeah. Okay. So we have passwords. I'll put that in the main block. And I'll reproduce quickly what we had last time, which was a kind of an example of the kind of thing that I was talking about. I want to get a list of the users whose password is PWD. What can I do in order to make progress towards the solution? Well, one answer is, well, can I just do it for the one user for now, right? And then we'll see. So I'll name this. First, I'll name this user by password. And here, what I need to do is I need to just go through the dictionary passwords. And then, so here I want to say return a user whose password is PWD, right? So not all of them, just one, doesn't matter which one, let's say the first. So how do you get through a dictionary? So we go for user, and here I'll say PWD0 for a reason that I'll explain in a second. So this is just the way that we go through dictionaries for now, right? So it's always for key value in the dictionary name dot items, right? And what this does is it puts, in this case, Yippen user, coffee and PWD0, and then Benson user and milk and PWD0, and then Gershoyan user and coffee and PWD0. Why did I name this PWD0? and not like PWD? What would be the problem with this? Anyone? Yeah.
One of the parameters.
Yeah, exactly. So it would run. It's just that it would overwrite the PWD. Right? Does that make sense to everyone? So I can say it, but what I want to say is if PWD equals to PWD, but that makes no sense at all. That would always be the case. So what I want to do is I want to go through passwords.items and change PWD 0. So that would be the current item in the dictionary that I'm looking at. And then if this PWD 0 matches this PWD, then I'm good. I found the user whose name matches, whose password, matches to PWD. And then here, I just want one user. So if I found them, then I can just say return user. Does that make sense? Questions? Yeah.
So why do you do passwords about items again?
So the reason is that I want to get both user and PWD 0, and that's how you do it. So I'll explain. So there is more kind of rhyme to this madness than it seems right now. So there is an explanation for why the syntax is the way it is, but we'll do it after the midterm. For now, that's just how we know to iterate through a dictionary, meaning get item, the first item, the second item, the third items, item meaning key and value.
And user and PWD 0 correspond to, say, yip and copy, right?
Right, that's exactly right. And then those are arbitrary names, right? So I could have said, K, but then I would have to say return K. So the generic name for that would be K because that's a key, but I want to give just meaningful names so that I don't get confused. Yes.
So you play more after the midterm, but this stuff is also in the midterm, right?
Yeah, so what I would explain is why it is the way it is. For now, you need to know what this does, and what this does is it puts, key value pairs inside this variable and this variable. So here, yip would be user and PWD would be coffee. And then the next time, user would be Benz and PWD 0 would be milk and so on.
It's later on show an example of dot value because I don't know exactly.
I can show it to you right now. So so the question was dot values. So what we've seen with dot values, sorry, quiet down, please. So what we've seen with dot values is looking whether something is a value. So for example, if you want to know if what's a good drink, water is one of the passwords, you can do that using water in passwords dot values. And this would be false. It's not. On the other hand, coffee is one of the passwords, so this would be true. Make sense? So that was also on the slides on Friday. All right. There was a question. Yeah, you're good. Okay. Anyone else? Yeah. Sorry, can you speak? Sorry, everyone, please stop talking and please speak up a little bit. I am using passwords here as well. Yeah. Yeah. Other questions? Yeah.
So basically, the for loop is iterating through each pair in the dictionary.
That's right. So each key value pair. Yeah. Yeah. Okay. Does this make sense to everyone? Okay. Is there someone who wants more of an explanation of this? Seeing none. Okay. So now I want to get back to the original problem. So the original problem was look up all the users whose password is PWD. There could be multiple such users. So what I'll do is I'll copy this guy. So the only change that I need here really is to say if PWD equals to PWD0, I just need to add the user to a list of users that have that password. So I'll do my usual pattern of this doesn't look right. Sorry, so I'm not free change like the spacing there was messed up, so I just fixed it. So the way I fixed it is I just like, so again, shift home or control shift left and then backspace, and then from here, the cursor is over here and I'm pressing enter. So here, what I'm gonna do is I'm gonna set up a results list and I'm gonna append to this list as I go. At the end, I'll just say return result. Does that make sense? So same thing, except instead of right away returning the user when I have a match of the password, I'll say just go through all of them, and then if you have a match, just append user to result. So here I can say, appended user. So this is just kind of for demonstration purposes. And then res is now, and I'll print res like so. Make it smaller for a bit. So here I'll say look up users by password, and I'll say passwords, and I'll say coffee. And if I run this, what I'm going to see is I appended yip to res, and res is now yip. And then I also found the pair Gerjoy coffee, and again, coffee matched coffee, and I appended Gerjoy to the list as well. Then I ran out of key value pairs, so I got to this line and I returned result. Does that make sense to people? Questions? All right. Oh, there was something, or just stretching? I think just gesticulating. People in the fourth row from the back. Yeah, it's actually you. Okay. Anyway. Okay. Okay, so moving on. Okay, let me check Discord. Okay. Okay, so there's questions. Okay, so how should we practice with a past midterm? Should we type the code or just handwrite it when practicing? What I would recommend is sit down with one midterm the once and practice handwriting, because you don't want it to be the case that the first time that you're writing code on paper is on the morning of the midterm. That might be a bad time. On the other hand, other than that, I actually recommend checking your code in Paizo and debugging it if it doesn't work. And that's because that's the way that you learn and build muscle and gain an intuition for what works, what might work, what kind of doesn't work. And furthermore, if you write it on paper, you don't know if it's right. And if you need to know, you're exactly the person who won't know. So Paizo will tell you though. So just try it in Paizo. So I think that's like one of the things about this course again, is that Paizo really keeps you honest in a way that a notebook never will. Okay. The TAs will though. Okay, so this is okay. Okay. Surprisingly, the trolls are correct. Okay. I'm not saying who the trolls are. All right. So, okay, next thing. So I want an example from, I think this is question 5 from 2022. So I usually try, so the midterms are traditionally around Halloween, and I try to have like Halloween themed questions. So this is why this year's is a little bit early. I'll do like one Halloween question if I can figure out a funny one. Okay. So this is the information. So what we have here is a dictionary where the keys are strings, right? So there is a key that's house 1 in quotes, and there is a key that's house 2 in quotes, and then the values are themselves dictionaries. Right? So this is one value and this is another value. And then in those values, the keys are strings and the values are lists. Okay, so not the easiest question. So again, what's going on? So if you just focus on Halloween hole at house 1, what is it? Well, it's just this dictionary, right? So the dictionary is Annie has Snickers and Mars, and Johnny has Snickers, right? And that's a common thing where what you want to do is, if it seems big, just make it as small as possible, right? So this dictionary seems big, it is big. But if you focus on Halloween hole at house 1, what is it? Well, it's nothing much. It's just the keys are names and the values are lists of candy. Yeah.
So when we use dictionaries here instead of like just a list within the list within the list for like make it look nicer.
Well, so the question was, would you use dictionaries here because it looks nicer than nested lists? And the answer is, well, it doesn't just look nicer, it's that it's easier to use, right? So you could, like in our initial password example with parallel lists, you could do something like a dictionary without using a dictionary. So that's the example from before with the login, right? If you remember. But this is actually easier to use, produces less bugs. So this is better, not just because it looks nicer, it's also like more useful. All right. So what the question asks is write a function that takes in the dictionary in the format like the above and returns the name of the kid who collected the most candy items. Okay, so again, if I'm looking at the question like this, so this would be one of the more difficult ones. A lot of the time, what works is just saying, okay, like, what are the examples? Why do they make sense? Right? So the example here is the luckiest kid is Annie. And that's because Annie collected 4 candy items in total. Why is it that Annie collected 4 candy items in total? Well, because Annie got 2 candy items in house 1 and then another 2 in house 2. On the other hand, Johnny only got the Snickers in house 1 and Jackie only got the coffee break in house 2. So that's fewer. Does that make sense? Okay. Does the question not make sense? The question, not like what the answer is. Okay. So the next thing we want to do here is try to answer the question, right? So what would be, and if you know the answer, pretend that you don't. So what would be a way to get to the answer? acknowledging that if to get the answer, you must know the answer, but apart from that. So what's like a quantity that would be useful here? Yeah. Yeah, like how many candy items each kid got would be really useful. Right? So how to do that? So let me so this would be, I think it's called houses, is that right? Oh, it's called Halloween Ho. Okay. Right. So let me quickly, and by the way, this is also useful. So just make up some data. And if the example seems like it's too large, just make up a small amount of data. So let me do that. So I'll say like house 1. Let's call it Ben. And then let's say Annie got just name generic brand candy that the people were cheap. So the candy is called like 1 and 2. 2Z, so that it's clear that it's not just a number. Okay, so that's like the smallest possible example. So one house named Ben where Annie got those candies. Right? So if I want to add another kid, I can add another kid. So let's say that Jackie got, 3. Does that make sense? So then in SF, let's say that Annie got 1 as well, and then Johnny got 5, 6. Okay. It now occurs to me that it would be funnier if the kids were collecting midterms, but okay. All right. So now I want to be able to say count candy. And then HH, and let's say Annie. Sam likely. And what would the answer be? How many candies did Annie get? 3. Okay, you have not forgotten everything since you got admitted to Anxi. I'm happy about that. So why 3? Because Annie got 2 in Ben and Annie got 1 in SF. Yeah. Make sense? So, okay. So let's make it even more specific. How many candies did they get in the specific house? So what would that be? So we'll go to the specific house. So we'll say Halloween Ho at house. So if it's Ben, for example, we are just focusing on this. Right? And then here we are only interested in Annie. So in general, this kid. So what we want to know is really how many candies are there over here. So how do you get that? Well, you say house at kid. And that's going to be this list here. Right? And that's because HH at Ben is this guy. And then this guy at Annie is this guy. And what we want to know is how many candies in this list. And the answer is just the length of the list. Make sense? Okay. So now that we have that, let's write count candy without the house. So again, Halloween Ho and then kid, but I don't say the house. So that's the original question that I ask. Right? What do we need to do here? Well, just basically this, except add up all the candy from the different houses. Right? So again, a pattern that we've seen this lecture as well. I'll say result initially is 0, and then go through all the houses and see how many candies the kid got in that particular house. So I'll say for house dictionary in HH items. So what would that do? It would put Ben in house and then house dictionary for Ben in house dictionary. And then it would put SF in house and it would put this dictionary in house dictionary. And then I'll just say add up return results. Right? So if this makes sense to you, think about it as like forget what this does, just call it in order to get the number of candies that the kid got at that particular house. And then all we need to do is just go through the different houses and add those up. Make sense? Yeah.
It's still for a specific kid.
Well, I mean, it's for this kid. Yeah, but this is a variable.
Yeah.
Yeah. So now, because so we don't want like the sum total of all the candy as well, right? What we want is we want which kid got the most. So now that we've got this structure, the problem is the same kind of problem as the location of the minimum in the list, if you remember that from Wednesday. What we want to do is we want to go through all the kids and see which of the kids got the most. So I'll just do that. What was the name of the function? Luckiest kid. So this would be HH. So what I'm going to do is I'm just going to go through all the kids and I'll see how much they got. And I'll keep track of which kid got the most so far. There might be repetitions, but that is fine, as long as I compute the amount of candy for each kid the once. So luckiest kid so far is Arthur Chan. And then, okay, Evan Benz. you can look up how much who makes on Ontario Sunshine List. So don't do that. It's tacky. Okay. So and then amount of candy is -1. So that Evan Vance is never the answer. Right? So now what we want to do is we want to go through all the kids. So the way I'll do it is I'll say for house dictionary in HH short items. And then I'll go for kid whole in house dictionary dot items. Wait, you're doing it, aren't you? Okay, so now I have the names of the kids and I can update this, right? So kid whole is hey. So sorry, guys, I have 1 more minute. So kid whole would be pound candy. HH, sorry, I did need the kid. HH kid. And then I'll say if kid whole is greater than amount candy. Okay, I feel like I lost you, but I do need more time and I spent some time shushing you, so I get to keep that time. So give me 60 more seconds, I'll be done and we'll explain more on Wednesday, okay? Shh. So we'll say if kid whole is greater than amount candy, then this is the luckiest kid so far. So we'll say luckiest kid so far is kid, and amount candy is kid whole. And that's it. And the end will return luckiest kid so far. That's it. Don't you feel lucky? Okay, I will see you Wednesday. I will try to announce office hours for Tuesday. There's office hours on Wednesday that are regularly scheduled anyway. I'll see you. Bye.
So please confirm that the lab this week is canceled.
Yeah,
So-
that was announced.